remember back in elementary school that your teacher would have like a jar on their desk and it's like, how many marbles are in here? You can get a treat if you get closest to it. No? Yes? That's me. Every time I was always right. It was great. It was a great time. So with that being said, suppose your teacher wanted to implement a new reward system. When a student does something great, they randomly pick a bead from the bead jar. If the bead is red, they get a piece of candy. If not, they don't win a prize. The question is, what are the chances that a student chooses a red bead? Each group will get a sample of beads and will create a confidence interval. That's going to be an important word to estimate the true proportion of red beads. The groups with the smallest interval that captures the true proportion wins a prize. Okay, we're not going to do this. We're going to kind of go through this pretty quickly. Sorry, I don't have like a ton of beads. So we're going to select a sample of 20 beads from the jar, and we're going to calculate the proportion of beads that are red. Okay, so let's say that we pull a sample and we pull out 0.35. 35% of them are red. Is this P or P hats? Why? Because it's a sample. Yeah, we don't invite the entire population to the party.
You have a dunce hat.
Yes, a dunce hat. Okay, this is called your point estimate. Your point estimate. Okay, so for the true proportion of red beads, identify the population, parameter, sample, and statistics. So what's the population? No. What's the population? All the beads in the jar, right? Cool. What about the parameter? What is that?
The size of
About the excommunication from this pod. No, I'm just kidding. The true proportion, so P is equal to the true proportion of red beads. So it's kind of like, where are you pulling your sample from?
Outer space.
And then what are you actually trying to find? Yeah. Parameters, like what exactly are you looking for? Okay.
Alex told me.
So for sample, you're going to have 20 beads selected. And then the statistic on that, y'all already told me, is party hat is equal to 0.35. Good. Again, they use this as the word point estimate. Yay. Now you're going to choose a value to add or subtract from your point estimate. This value is called the margin of error. To create an interval of values, remember the narrowest interval that actually captures the true proportion wins a prize. What margin of error do we want to use? Any guesses? Any thoughts? 5? What about, let's do 0.1. Let's do 0.1. Okay, and you'll see why in just a second. All right, so you're going to put plus or minus 0.1 because that's only about 2 more or less red beads. Okay, so plus or minus 0.1, and that's 2 or more red beads, roughly. This is lagging. Okay. Use your point estimate and chosen margin of error to create an interval that should contain the true proportion of red beads. So our point estimate, oh, sorry, that should have been on 3. Let me scroll down. 2. We're starting off strong. All right, so we've got 0.35 plus or minus 10. So what's 0.35 plus 10?
4.5. Wait,
0.45. And then what's 0.35 minus 10? 0.25. Okay. So here's the big thing. From 0.25 to 0.45, somewhere in there is my true proportion of the population. Does that make sense? Okay, so from 0.25 to 0.45, That's going to contain my true population proportion. Okay. I don't know. Maybe this isn't writing correctly. Okay, so this is what we call a confidence interval. I'm confident that the true proportion lies within that. Yeah? Okay. So the way we found that is we took the point estimate, and we added and subtracted the margin of error, also known as MO. So how confident do you feel that we have captured the true proportion? Okay, give me a percentage.
100.
Not less than 100. 99? Y'all are 99%? Okay, let's go with like 90%. So we are 90% confident that the interval from 0.25 to 0.45 captures the true proportion of red beads. Oops, spelled that wrong. Red beads in container. This little sentence that we just wrote down is how you interpret confidence intervals. You're welcome. So we say that we are whatever percent confident that the true proportion lies between this number, and then you put it in confidence. Okay. That's one of those. Huh?
This is classified information.
Exactly. So that's one of those like you literally can just like copy and paste that statement every time. Okay. Don't get that question wrong. Yeah. Hardest part is actually like calculating it. All right, one of the groups got 0.37 and 0.43 as their interval. What was their point estimate? And does your interval support or deny this claim?
That's 0.0. That's 0.06.
Say again. Why do you say it's 0.03?
40 plus 0.06.
Ah. Okay. So just like what he said, because he's absolutely right. Did you just guess? That's crazy. Okay. So he just said from 0.37 and 0.43, if I add them together and then I divide by 2, what do I get? Say again? 0.4. Okay, so 0.4 is in between those two things, right? What was their margin of error? So this was the point estimate. Now, what is the margin of error? How do we figure that out? Subtract what? Okay, so 0.43 minus 0.4 is what? Try again. 0.43 minus 0.4 is 0.03. So my margin of error is 3%. Does everybody see how I got that? I got 2 intervals. I find the middle for the point estimate, and then I subtract maybe the upper minus the middle. It should work for both sides too. Okay. Are you okay on that? Go ahead. Okay, so here is my interval, 0.37 and 0.43, right? My point estimate, that means that I took a sample and this is what I got, is lying right in the middle. Yeah, so that's my 0.4. If I add 0.03, I get this number. If I subtract 0.03, I get this number. So you're talking about finding the interval. Let's say that they already had the interval and they gave it to you. Do the reverse. That's what we just did. Help? Does that help? Okay. All right. One of the groups claims that the true proportion of red beads is 0.25. Does your interval support or deny this claim? So what was our interval? 0.25 to... Okay. Does this interval support our claim?
The aliens tell me yes. In a way. The aliens tell me they support it.
And it's got me.
Yeah. We could say that it slightly supports the claim. Remember those LY words? Slightly. But it's on the border, right? So, but it could happen because it's in our interval, right? We're saying from this number to this number. Yeah. So it slightly supports our claim because it still is within the interval. I don't like it, but like, you can't say like no, right? It's still within like that, what, 0.1%? I'm sorry, 10%? All right, flip it. Okay, let's summarize. Okay, so interpreting a confidence interval. We learned that a confidence interval is found. Confidence interval is found by taking your point estimate, adding and subtracting the margin of error. Everybody okay with these acronyms? Okay. For interval, let's say they give us A comma B. If I'm trying to find the point estimate, so if I'm doing the reverse, I'm going to add them together, divide by 2. So just like what he said earlier, we're going to find the halfway mark. If we're trying to find the margin of error, you can subtract the 2 and then divide by 2, and that gives you the margin of error. So if you're having to work backwards, that's how you do it, which is what we did. Okay, now we found a fancy little phrase that we're going to use when we interpret, because that's our favorite word in stats. I was going to say psychology. That's where I'm at right now. Yeah. I don't even know. Oh, we are blank percent confident that the interval from A to B captures the true, and you're going to put context. If you don't put context, it's wrong. And all values between A and B are plausible.
I don't know what I just said.
Okay. If it's like on the border, you can still say it's slightly plausible. If it's outside of that number, no, wrong. Okay. You okay? Go ahead.
Why did we choose 1 times 10?
We just picked one. Eventually, we're gonna get to a point where you actually like calculate it. But we're not there yet. Sit tight. It's gonna happen. Or they'll state like use a margin of error of this. Yeah. All right, your turn. Try your check your understanding. So ABC. First one should be easy. The second one should be easy. And the third one should be easy. All right, ready? Go.
Oh, my.
Okay, so we can't say that the claim is supported. Can't say for sure that a majority of adults pay for subscriptions they don't use. We do not have convincing evidence to support the claim because our interval contains values that are both above and below 0.5. We can't say for sure that a majority of the adults pay for subscriptions they don't use. We do not have convincing, spelled wrong, evidence to support the claim because our interval contains values that are both above and below 0.5. This is like when they do, you get a lot of questions about like the presidential campaigns and that kind of stuff with these confidence intervals. That's how they decide who's probably going to win. Yeah. You got to be above a certain confidence interval in order to make sure that you are absolutely going to win. Okay. Gucci. No questions? Solid. Good. Okay. I know we're doing a lot of jumping. It's fine. We're fine. Okay. Go to your 7.1, 7.2, 7.3, 4 homework. We did a little bit of 7.1, 7.2. If you came to Lion Time, we did a little more practice, which is great. But I want you to look at 7.3, 7.4, since we've already gone over it. Okay, get a little bit of practice. Do the multiple choice. Respectfully, y'all suck at the multiple choice. Yeah? And I don't know if it's partially because now you have 5 options instead of 4 like you've previously had. So there's that. Because remember, we have A, B, C, D, E. But you have to practice them. You have to look at the wording of those questions. Yeah? You don't get good at it magically. You got to practice it. And sometimes it is tricky. Okay? So we're looking at 7.3, 7.4. If